Properties of waves, such as height and distance between, are useful for describing waves. Amplitude is the first measurement. It's the maximum distance the particles of a medium vibrate from their rest position. You measure it from the top of the wave to the rest position, or from the bottom of the wave to the rest position. The rest position is the point where the particles of the medium stay when there is no disturbance, so it would be like a flat lake. Larger amplitude means more energy. It takes energy to move the particles of the medium away from the rest position. Think about making waves in a swimming pool. If you want to make a bigger wave, you have to push harder. Moving the particles farther from the rest position takes more energy. Waves with larger amplitudes carry more energy. So the wave on the left carries more energy than the wave on the right. Radio stations. AM radio. AM stands for amplitude modulation, which means that the height of the wave is changing. Wavelength is another measurement. It can be measured from any two corresponding parts that are adjacent on a wave. So it can be from a crest to a crest, which is the top of a transverse wave, or the trough to the trough, which is the lowest part of a transverse wave, or from a compression to compression, or rarefaction to rarefaction on a longitudinal wave. Shorter wavelength means more energy. So shorter wavelengths carry more energy. The one on the bottom shows a shorter wavelength, so that is more energy than the wave on the top, assuming they have the same amplitude. So if you're trying to make waves in the swimming pool again, if you want to make a shorter wavelength, you have to hit the water many more times, which takes more energy. Frequency is another measurement. It tells you how many waves are passing in a certain amount of time. So in this illustration here, it shows that the person they go down, up, so they have two waves passing by in 10 seconds of time, so that's going to be 0.2, and the measurement for frequency is hertz, Hertz, abbreviated Hz. FM stands for frequency modulation, or frequency changing. The frequencies on the dial are measured in megahertz, which means million hertz, so that's millions of waves per second. V103 is broadcast at a frequency of 103 million hertz. Higher frequency, more energy. Vibrating quickly requires more energy than vibrating slowly. Higher frequency waves carry more energy if the amplitudes are equal. Wave speed is the speed at which a wave travels. So right here it shows the wave on the bottom is traveling at a faster rate. So frequency and wavelength relationship. There's a formula for this, and the symbols are wave speed, which is V, wavelength, which is the Greek letter lambda, looks like an upside down Y, and frequency, which is F. So wave speed equals frequency times wavelength.